Hello and welcome to this edition of Tech Talk. I'm Eddie Ambler.
And I am Leo Alvarado.
In this session, we will be discussing how to develop modern applications using Oracle Cloud databases. As part of this discussion, we will introduce you to the Oracle Cloud Database Services. We will also discuss the Oracle Converged Database, highlighting what it contains and how it simplifies application development. We will also walk through a few architecture design patterns and demos of the Oracle Converged Database and Cloud Database Services in action. Oracle offers a range of database services in the Oracle Cloud. In general, we can break them down by the scale and performance requirements for the system, and if the system will reside in the Oracle Public Cloud or in a customer data center. The Oracle Database Cloud subscriptions range across the spectrum with service editions and automation levels to meet your SLAs and database management needs. Our base database service offers both Oracle Database Standard Edition and Enterprise Edition models, which allows you to select from single instance or 2-node rack enterprise databases with this service. When you need more scale or performance, you can choose from our Exadata database service, which is available in the public cloud or on Cloud at Customer. Exadata Cloud at Customer offers the same cloud economics and cloud automation as Exadata database service in the public cloud, but it is deployed in the customer's data center. And for those who want a fully managed experience, you can choose from one of the autonomous database offerings. Delivering Oracle Database in the cloud on the Exadata platform extends the proven value from on-premise converged infrastructure into the cloud, allowing for cloud automation to further simplify and optimize the operational layer. Cloud automation not only simplifies operational tasks, but also reduces the time to market while increasing the quality of the deliverables. Just like engineered systems on-premise took deployment time from months to days, the evolution of cloud database service has taken database deployment time from days to now hours. Oracle's multi-model converged architecture supports multiple data types, data models such as spatial, graph, JSON, and XML, and algorithms such as machine learning, graph, and statistical functions, and workload types such as operational and analytical within a single database. At no additional cost, customers can now take full advantage of the enterprise-class performance, reliability, and security of the Oracle database in the cloud. Think how powerful it is to be able to perform spatial analysis alongside your transactional data, or to conduct the processing of spatial imagery data coupled with data warehouse data for location-based inquiries. The Oracle Database is a converged database that provides best-of-breed support for all data models and workloads. When conducting application development with Oracle Cloud Database Services and the Oracle Converged Database, developers get to use the popular dev tools and APIs that they love while still being able to work with the data format, access methods, and workload characteristics that they want. The analysts and data scientists also get what they need, which is easy access to uncurated and curated data that is consistent. In all cases, developers get what they want: the use of popular dev tools and APIs, the ability to run a single SQL query across all data types, and the ability to run transaction across all data types. A developer using JSON might use the get and put functions to work with their data, which is great, but they can do much more than that. Because Oracle Database is a multi-model database, users are not restricted to using just one way of accessing their data. For example, developers can query the JSON data with SQL and use GraphQuery to look for relationships. With the use of Converged Database, the IT team also gets what they need, which is a database system that provides operational simplicity, scalability, reliability, availability, and has the security characteristics that they want at a lower cost, even as the other groups get what they want. With the Oracle Converged Database, the organization as a whole gets the benefit of centralized data while also providing the support to build decentralized applications. Operational reporting, ad hoc query, and security are all easier or better when done via the Oracle Converged database versus when needing to do it against a variety of point solution databases that each have their own technical support needs, varying APIs, language constructs, and integration needs. The Oracle Converged database not only provides you with a rich set of data models to choose from, but also provides you the choice as to where you can run your database. The same Oracle database software that runs on-premise now also runs in all of Oracle's cloud database services, independent of the deployment model that you choose. Portability equals choice. Oracle Database has been the most portable database solution for more than 40 years. Let's take a quick peek at how we can write a SQL statement that accesses data from various data models using the Oracle Converged database. I have recorded a demo that I will walk you through that is less than 2 minutes long, but will quickly show you how the Converged database can simplify your data access needs and eliminate all the need to move and transform data. In this demo, we will start by evaluating using the Oracle database to handle JSON data. We can query JSON with SQL DML or SOTA API. For this demo, we will focus on the DML operation. Let's start by creating a table with a JSON column. Note the use of the isJSON constraint in the syntax. Note also that we can create indexes on the JSON attributes that we want to query on. Let's execute our create statements. Now let's insert some data into our JSON customer info table using standard SQL statements. Now that we have inserted some JSON formatted data, let's write a SQL to select the complete JSON document. Now let's write SQL to select individual attributes from our JSON document using dot notation in query path. Now that we have seen the Oracle database work with the JSON data model, let's look at adding data from other data models to our query. For our demo, we have created 3 tables. Customer info, which has data in JSON format. Orders, which has data in relational format. And payment info, which has data in XML format. Let's write a single select statement that gets data from all 3 data model formats. In our SQL, note that all of our tables are listed in the from clause and joined together using the keys in the where clause. Now let's execute the query and see the results. You can see that our output successfully returned just the data elements that we asked for from all of the different tables that held data in varying formats.
So now let's talk about the autonomous JSON database. So the autonomous JSON database, so it's a type of the autonomous database, which is a managed version of Oracle database in the cloud. So the idea is you don't have to install it, configure, back it up. All that is done for you. So you just need to create or spin up an instance and it's ready to go. The autonomous JSON database, or AJD for short, is the version of the autonomous database intended for building interactive applications and microservices that primarily need to store JSON data, and that you can connect to it using either JSON collection APIs or SQL. And in terms of functionality, it is the same as the ATP, or the autonomous transaction processing. More of the AJD, it is intended to compete with the NoSQL document store. So if you heard about MongoDB, Couchbase, Azure Cosmos DB, AWS Document DB. So it provides most of the same benefits typically associated with a NoSQL stores, but will provide you with elasticity, like meaning you can scale compute and storage as the database grows, and you can even enable auto scaling. We've also seen that this NoSQL stores advertise that they can maintain latency. So what it means. So the autonomous database or the autonomous JSON database can also do this, but not at the cost of durability and consistency, in which it provides you with a single digit latency. It is highly available and low cost. So in fact, we also have our autonomous JSON database on our always free tier. So the question is, why developers love JSON? So why do they love JSON? So simply because JSON is a fairly simple way to describe or model your data. So it has a small set of types like objects, strings, numbers, and booleans that can easily consumed by your application. So you can easily map it to your application objects and do read write without joins. And as you may know, JSON has grown in popularity as the data storage format uh, over the past decade. Like it's supported by most programming languages, and over the past decade, so MongoDB and other NoSQL document database have grown in popularity, and as a result, we have added this JSON collections and related APIs to our Oracle database that will provide a similar development experience. And in fact, most recently, we have added the Oracle database API for MongoDB, which allows you to connect to to connect your Mongo tools and applications directly to your Oracle database. So in the next section, I'll be covering what exactly a JSON collection is, and how it fits to the relational model. Okay, so a document database is a type of non-relational database designed to store, retrieve, and manage document-oriented information. So rather than having a schema defined upfront, so document databases allow for storing data in collections consisting of documents. So NoSQL databases and JSON databases are types of this document databases. So a document is a JSON value. So the structure is flexible and have a unique key value. Then a collection, it contains a document. So as you can see here in the screenshot, so you have a PO document. And then a database contains collections that can be accessed programmatically with no SQL required. Now, your database that contains collection is your schema in the relational model. So as you can see here, so your collections created in the database named admin will be in the admin schema. Now, for the collections, so collections are an abstraction or view of a table with a single JSON column. So as you can see here, so we are trying to create a table name and employee with a data type of JSON. Okay, and in inserting a document into a collection inserts a row into the backing table. So as you can see here, so in it's we're trying to insert into the employee table, which is the same as doing it in inserting a document into the collection named employee. Okay. So here, you can also run a SQL version of your JSON query. So the filter in JSON, it's your SQL query in your RDBMS. So when filter expressions are executed as SQL over a backing table, the benefit here is that you can fully utilize the core Oracle database features, such as indexing, cost-based optimization, and more, and it gives you the option to query your data via JSON or via SQL. So the next one is a quick demo. So let's take a look at how developers can use Soda to persist and manage JSON documents. So here you can see we're creating a connection which is identical to connecting to any Oracle database, which we can then use to get Soda document database back. Then you can see here that the Soda API uses collections rather than the tables to persist JSON documents. And typically applications developed with Soda will use a query by example API to select data, but they can also use SQL when needed. And definitely you can update the JSON documents via the Soda API as well.
You know what? I think, Leo, what would be good at this point is if you have any questions, if you just go ahead and put them in the chat. Then when we get to the end of the presentation, we'll circle back and make sure that we answer any questions. But I want to kind of keep us going on the content itself. So we'll, just to pause here just for 30 seconds to give folks a minute to maybe enter their questions into chat. And like I said, in the end of the next section, we'll actually read those questions and make sure that we answer those. So. All right. So with that being said, Leo, they can continue to write their questions as you continue on here.
All right. So let's proceed. So now let's see how Oracle makes it easy for you to use modern data models to handle different types of data and types of workloads in decentralized apps. So here I wanted to show you that application development in Oracle Cloud is easy. So you can bring and use the tools that you love to modernize your applications and optimize your development processes. So it is open and it's open and modern. So as you can see on our diagram, the screen, so there are a ton of tools that you can choose from. So let's go through it. So at the bottom, you have your underlying foundation, which is the Oracle Cloud Infrastructure, or OCI, which is built for anyone looking for higher performance, lower cost, and easier cloud migration. And it is open and modern. So meaning we offer you a set of cloud native services that some are based on the best of open source, including containers, Kubernetes, serverless functions, integrated registry, and build processes and more. Now, for the DevOps and agile development, so we offer tools for software development life cycle management, or SDLC, such as your version control systems, build tools like Maven and Gradle, infrastructure, platform, and applications automation. We also support major programming languages and frameworks such as your Node.js, Python, Java, and other frameworks like Micronaut and Helidon. And Oracle Cloud provides automation functions that allows you to do things, create like gold images of your database or application tier that can be used as part of the cloud automation API calls or as part of your infrastructure as a code deployment. Now, Oracle Cloud also has this simple UIs and APIs that can enable you to be able to capture an entire environment as a stack into in a form of a Terraform, or capture just a set of desired elements. Then definitely you can use Terraform and Ansible to automate and deliver your application stack as a code. Now, today's modern applications are data-driven applications. So that requires the ability to handle many different types of data. This could be relational, spatial, graph, document, and more, and different types of workloads, such as transactional, analytic, or even a combination of both, like HTAP workloads, machine learning, IoT, and so on. So Oracle is a converged database, and that the Oracle database platform is a multi-model converged architecture that supports multiple data models such as spatial, graph, JSON, XML, and also supports multiple workload types like operational and analytics, or could be in hybrid transactional analytic workloads. And also supports multiple algorithms. So as Eddie has mentioned a while ago, so machine learning, statistical functions, and even in-memory operations, that all within in a single database platform. So this will allow developers the ability to leverage the best data model to access the different data types from within one data platform, while still being able to access all the data from a one SQL call. And utilizing the converged database also allows the developers to take full advantage of the enterprise class performance, scale, reliability, and security of the Oracle database to quickly deliver their applications. And since all these data types and workloads are built into the Oracle Converged database, then you just need to call SQL to use them. So a single converged database is far less effort and risk to deploy, secure, scale, and operate compared to a multiple single purpose databases. So it also removes the need to have to move and reconcile data between database, and having the ability for the same SQL, REST APIs, and transactions operate across all data types and workloads truly simplifies the developer's work efforts and improves your application time to market. And this simplification enables small decentralized application dev team or app dev teams to use modern data types of workload. And by eliminating the complexity introduced by a single purpose data store, so converged database dramatically simplifies your decentralized application development. So now let's walk through to more examples of how Oracle simplifies the development of a modern decentralized app. So let's have a look at this example as the online store. So here, I mean, traditionally, all aspects of the application will be collocated in one big monolith application and running against a one big monolith database. While the microservices architecture for the online store looks very different. So as you can see here, applications built with microservices are a suite of loosely coupled services. So this microservices are normally organized around business capabilities and are independently deployed with their own database with extreme horizontal scale capability. So in this example, in this online store, we can see that the application is broken into 5 microservices. So you have your recommendations, catalogs, orders, delivery, and analytics. However, the integration for all of these databases can create a massive macro level complexity. And the microservice design pattern encourages a data store independence in which the developer chooses the right database point solution for the characteristics of the individual service. And the concept of independent data store or databases introduces also complexities that becomes a pain as the granularity and interdependence of the microservices grow. And to address these needs, the developers must decide between the use of a single purpose best of breed database for each type and workload, or to use a single converged database for all the data types and workloads. So let's take a look at using coded events for executing application logic. So coded events can be used to implement application logic or actions that span across microservices. And coded events are propagated at the application level using event platforms like Kafka. Then for coded events for data changes, it is imperative also to notice that two operations are involved in event sourcing. So first is the data change being made and the communication event for that data change. Therefore, a transactional consideration and inconsistency or failure causing a lack of atomicity between these two operations must be accounted for. That's why the functionality of coded events for data changes are also used to propagate data changes between your microservices using an event platform like Kafka. So we've seen some of the examples. Now, I wanted to ask Eddie to help us through on walking us through on how Oracle can simplify this microservices architecture.
Thanks, Leo. Let's take a look at how we can use the Oracle database features and Oracle Cloud Database Services to simplify this microservices architecture. Let's start by replacing multiple single-purpose databases within a microservice with a single converged database. It's much easier to tune, secure, scale, and troubleshoot microservices that use a single data store. On our diagram on the screen, you can see that we've replaced the numerous point solution databases with fewer converged Oracle databases. Next, let's leverage Oracle's multi-tenant technology to containerize the converged databases into fewer physical databases using pluggable databases. Note that we now have a physical container database known as a CDB, which houses the pluggable container databases. This model allows me to manage many databases as one. In this step, we also included the use of Kubernetes operators to orchestrate pluggable database operations. It is suggested to implement application transactional events with transactional event queues where possible. This will enable events and database changes to execute in one atomic transaction. In our example, we use Oracle Transactional Event Queues, which is a messaging eventing system that is actually part of the Oracle database system itself. Because it is a part of the database, it can conduct data change being made and conduct communication of that data change event in the same local transaction and provide the atomicity guarantee. This is not something that can be done between Kafka and any other database. In this model, we will continue to use Kafka for heterogeneous events. In this step, we will use Oracle Golden Gate to transactionally publish and consume data events between microservices, applications, or other clouds. This removes the need to hand code, capture, and apply state changes. An application can have both coded events and data events. Golden Gate can be used to publish data events to Kafka. Where appropriate, we can use low-code technologies such as Apex, which is also part of the Oracle database, to generate most enterprise applications or microservices instead of hand coding them. The Apex low-code approach can be used to remove the complexity of needing to manage a separate application tier and data tier. As part of the final step to simplify the microservices architecture, use cloud technologies to deploy and manage databases. You can use the Oracle Exadata database service to automate and optimize the entire database infrastructure in the Oracle public cloud or on-premise with Exadata Cloud at Customer. For a fully managed database experience, use the Autonomous Database to make your database self-managing, self-repairing, and self-securing. As you have seen, rethinking database architecture to embrace modern application development methodologies can result in a dramatically simpler and more robust application. Our diagram shows the starting point of our simplification process, where Leo had so eloquently laid out a very common microservices architecture. On the right, we took the microservices application and were able to simplify it by leveraging the Oracle database features and the Oracle Cloud Database services. Thanks for choosing to spend your time with us. Our mission is to help people see data in new ways, discover insights, and unlock endless possibilities. I hope you're all excited about what you've learned and are ready to apply these techniques to your next generation application. Now let's check on what questions are in the chat. Leo, did you see anything that we needed to address before we told folks where they can find more information?
So the question is the autonomous JSON database is available on the free tier?
Okay, yeah, you want to go ahead and take that one?
Yes, well, yeah, definitely your autonomous JSON database, or AJD. So it's available on the always free tier, so they can test out using the autonomous JSON database also for their NoSQL stores requirement.
You know, while you were talking about the autonomous JSON database, I think something that would be awesome to just to kind of point out to the developers is, you know, if you've got a workload and you just need a small database, you kind of have two choices. You can use the base database service, which we talked about, which runs on VMs to spin up a VM that has as little as one OCPU allocated to it, or you can use autonomous database shared, which gives you a fully managed database experience with as little as one OCPU attached to it as well. So it's very easy to spin up a small prototype project at very minimal cost. And again, you're not locked into any long-term contracts. The OCPUs in use are billed by the hour. So, you know, if you only need an environment for an hour, you just pay for an hour. So the cloud model of pay for what you use is preserved in either one of those models. You know, I see one of the questions that was asked was, you know, they wanted to understand if there was an additional cost for the transactional events messaging. And the answer to that is no, it is a free feature that is included in the database enterprise edition offering, similar to like the Apex feature that was discussed. So great question. Well, I don't see any other questions at the moment, Leo. How about on your end?
Wait, there's one more. Okay, so we're not ready yet for autonomous. What other cloud DB services we can subscribe to?
Okay,
Well, yeah, as I think you answered that
yeah.
a while ago. Yeah. So Yep.
Yeah, I mean,
So
we'll repeat it again. It's worth it, right? So
okay.
within the Oracle Cloud Database Services, we have essentially three database offerings. We have our base database service, which runs on VMs. All right, you can go from one OCPU all the way to 64 OCPUs on a single VM, and we have the ability to run up to two VMs in a two-node rack configuration, which gives us twice that number of OCPUs. It has the ability to give us about 80 terabytes of storage access there. When we, like I said, the second one is when we need a little bit more than those boundaries, we can bump up to the Exadata database service, all right, which can be run in the public cloud or in the cloud at customer. In the public cloud is a 48-hour minimum time to use the Exadata database service. And beyond that, you pay by the hour as you use the service. So no long-term commitments to using that service as well. And ultimately, when you need that fully managed service, right, you can choose from the third type, which is our autonomous database. So great question.
Okay. So maybe we can proceed on showing them where they can find additional resources. So we have an external Slack workspace. So you can join our Slack workspace and get access to the contents that we are uploading to that workspace, such as the get started guides for all the cloud database service, for base database service and Exadata database service. We're also uploading there how-to demos and gifts, as well as to update you with the upcoming Tech Talk series. We're also posting their replays for our Tech Talk and featured blogs. And here you see how you will join the Slack database workspace. Okay, so we're inviting you. So join us. So join the discussion. Anything about cloud database services on Slack. So you can see the join link here. So here's the steps how to join. So you just need to click on the join link, log in your email account to Slack, check your email and configure your 2FA, and that's it. Welcome to our workspace. Now, once you join our workspace, you will also see two chatbots. I mean, AI chatbots that we have created. It's you can see it in the under the app. So there's a ask Ed and ask Debbie. So those two are AI chatbots to help on OCI, CLI, or command line commands if you're using it for your base database service and Exadata database service.
All right. Well, I hope you enjoyed the session. Again, I'd like to thank you for spending your time with us. I'm Eddie, and
And I'm Leo.
thanks again for joining us.